Day 241 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 241 and we're still going strong. Today we have question number 103, binary tree zigzag level order traversal. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand as possible. So let's get into it. The question says, given the root of a binary tree, return the zigzag level order traversal of its nodes values, i.e. from left to right, then right to left for the next level, and alternate between. So let's look at example 1 so we can see what it is exactly that they want us to do. So in example 1, we have the input root equals a binary tree 3, 9, 20, 0, 0, 15, and 7, which is represented by this picture right here. And the output is a 2D array. Each level is going to have its own array inside the 2D array. So it's going to be the output. The first array is going to be 3 for the root. Second array is going to be 20 and 9. And the third array is going to be 15 and 7. So let's see how they got this output from this input, right? All they did was we're starting from the left, right? So 3 will start on the root counts as starting on the left, right? So we'll put the 3 right here by itself. So the next level we're starting from the right. So that's why it goes 29, because we're going from 3. The 3 starts to the left, then we come down, start from the right, we go 29 like it is right here. And then we come back and do it from the left, and it goes 15, 7 right here, and that's the zigzag. It goes boom, 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 right? So it goes left, right, left, and that's how they got this output. Now, let's look at example 2, where they might try to throw some tricks our way where it's only just a root node, right? So in example 2, we have the input root equals 1. The output would be 1 because there's only one node to traverse, and after we traverse that node, we don't really have to do anything else. Similar in example 3, we have the input root equals a blank array. The output would be a blank array as well, because that means there are no nodes to traverse, so we could just keep the array as it is, which is blank. Now that we understand the question, y'all, let's get into the solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. Then after you do that, go ahead and like, comment, and subscribe. So first thing we need to do is we need to figure out how we're going to traverse through this binary tree. And today we are going to use a depth first search traversal in order to traverse through this binary tree. I know before we were doing the level by levels, which would be the breadth first search, but in this case we're going to use the depth with the D first search. So let's figure out how we're going to do it. And the first thing we are going to do, right, is we are going to need to create a private function. So we're going to come down here, say private func, call it DFS for depth first search. We're going to do underscore node. That's going to be a tree node. We can make that optional. We're going to say comma. Then we're going to say level, colon. That's going to be an integer. Then we're going to say ands, colon. That's going to be in out 2D array of integers, like so. Now, the in out keyword is used to indicate that a function parameter is passed by reference and not by value, y'all. This allows the function to modify the parameter's value directly, and then the change persists outside of the function. So that's why we're using the in out parameter in this function, so that we will be able to modify the parameter's value directly, and that's going to persist outside of the function. So now we're going to open up the brackets, and we are going to need to create a base case for if the current node is nil, right? So we could just stop right there, similar to example 3. So in order to do that, all we have to do, we can use a guard statement to do that, and we could just say guard let node equal node, else we could just open up the brackets and return, just like so, right? Now we need to check if the current level doesn't exist in the result array. We need to create a new array for it, right? So all we need to do for that is we need to come under this, and we'll say if ands dot count is less than or equal to level, boom, what we are going to do is we are going to open up the brackets and we're going to say ands dot append, open up the parentheses, open up the square brackets, integer. So we're going to add an empty subarray to the current level if the current level doesn't exist in the result array already. So we're going to say int just like this, come outside those brackets and put the parentheses just like so. Now we need to add the node's value to the appropriate subarray based on the zigzag order. So we're going to do that by, we're going to check to see if a level is even. That means we're going to append the value to the end of the array. And if the level is odd, that means we're going to insert the value at the beginning of the subarray, right? So that's how we're going to zigzag it. We're going to keep track of which level we're on. So to do that, we're just going to say if level mod 2 is equal to 0, boom, what we're going to do, we're going to say ands, open up the square brackets, level, come outside of that, dot, append, open up the parentheses, node value. So once again, if the level we're on is even, then that lets us know that we need to append the value to the end of the subarray, right? And if it's odd, like how it is, we'll put the value where this would be the first level, right? So this is an odd level. That's why we put this 20 at the beginning of this subarray, right? That's how we would know. We put the 20 at the beginning of the subarray, and then we put the 9, right? Whereas this level 2 will be even, so that's why we would append it in the left to right order, where it go 15 then 7. Whereas if the level is odd, then it go in the backwards right to left order, and it goes 20 to 9. So that's how we're going to handle that right here, by just keeping track of what level we're on, and depending what level we're on, we'll know which order to append the node values. So then we're going to say else, and then else, this is for if it is not not an even level, we're going to say ands, open up the square brackets, level, come outside that, dot, insert, open up the parentheses, node dot val, comma, at 0, which stands for at index 0. That's what that at stands for. Now we need to recursively check for the left and right nodes moving on to the next level, right? So to do that, we are just going to say, come down here outside of this if statement right here, and we're going to use some recursion. We're going to say DFS node.left, boom, comma, level, colon, level plus 1, comma, ands. Then we're going to say ands. So this and sign is used to pass a variable as an in and out parameter to a function. So whenever we're dealing with this in and out, we're going to have to use one of these and signs right here. The and symbol indicates that you are passing the variable by its reference rather than value, allowing the function to modify the original variable directly. So now let's do the same thing for the right side. We're going to say DFS, open up the parentheses, node.right, comma, level, colon, level plus 1, comma, ands, colon, and ands, just like so. Now, but we're not done yet, because remember that was just the helper function. Now we need to call it in the original function. So in order to do that, first we're going to initialize the result array, which is going to store the values level by level, right? So to do that, we need to declare a variable. We could call that ands, and we'll set that equal to a 2D array of integers, and that's going to help us return our output in this manner like this with the 2D array of integers. And then we just come outside that initializer with the parentheses. Now this is where we call the depth first search traversal, starting from the root, which is level 0. So remember, the root is level 0, this is the first level and this would be the second level. That's why this one would be the odd level, which is why we are inserting this node at the beginning of the value, at the beginning of the array, subarray, as we traverse through this. So now we come down here and we just need to start our depth first search. Sorry, y'all, that's hard to say. Depth first search, open up the parentheses, root, comma, level. So we're going to start at 0. So we're going to say ands. And now it's the in and out parameter, so we're going to say ands again. And now we just need to come down here and we need to say return ands, just like so. Now let's run this, see how it runs. Hopefully it runs like it's supposed to. Oh, we got a typo. Let's see, we had a little typo right there. Let's run it again, see what happens. Okay, we got another typo, boom. Moving too fast, I apologize about that. Okay, let's see. And it's accepted, y'all, so let's submit it and make sure it stays accepted after we submit it. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. Those some good numbers right there. Those the numbers I like to see. I hope y'all like to see those numbers too. Now, that concludes our lesson for today. But before we go, don't forget, get one more look at the code. This is the helper function right here. Get one more look at the helper function. That's all it is. And this is the original function right here. Get one more look at that. Go ahead and read it, learn it, love it, internalize all this good knowledge that we took in today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.